Alright, this third type of simple machine is called a wheel and axle. And so what we're going to have is we're going to have some big wheel, and then coming out behind that is an axle that would turn that's attached to it. So what I can do is I can turn this wheel. I can apply an effort force around this wheel, and then that in turn would also turn this axle. So when we're calculating the IMA for all these, the ideal mechanical advantage, again it's the same equation, dE over dr. So there's several ways you can think about that with the wheel and axle. I could take the distance I turned this wheel, and maybe I go around one time, which is the circumference. So that would be 2 pi times the radius of the wheel, over the distance that the resistance turns, and that would be around one time. So that would be 2 pi times the radius of the axle. But if you notice, if we did that, we could do that, circumferences, but if we did that, you'll notice 2 pi cancels out. So another way to calculate the IMA of the wheel and axle is the radius of the wheel divided by the radius of the axle. And of course, if you know, radius is just half of the diameters, right? Half of the diameters. So you could also just say the diameter of the wheel over the diameter of the axle. Either one would be totally fine. So if you get a problem and they give you the diameter of the wheel, then I would use the diameters of the two things. If they just give you the radius, then I would just use the radius of the two things. Now, this is assuming that we want to have a mechanical advantage of greater than 1, so we're turning the wheel to turn the axle. And so it would be the radius of the wheel over the radius of the axle. But what if I turn the axle, which would then turn the wheel? Well, then the mechanical advantage, of course, is the diameter, we'll say, of the axle divided by the diameter of the wheel. Now, the axle is always going to be smaller than the wheel, right? So this means the mechanical advantage, the IMA here, is going to be less than 1, okay, for if I'm having the axle turn the wheel. So normally when we're talking about a simple machine, we're thinking about the wheel turning the axle, so we have a good ideal mechanical advantage. Now the reason we might want to turn the axle to turn the wheel might be like mousetrap cards that we do in physics, where if I turn the axle one time, that turns the wheel one time. So if I have a really small axle compared to my wheel, I can turn the axle one time and use that much string, and that'll make the wheel go around, and if it's a really big wheel, it'll turn that much horizontal distance. So for a little bit of pulling string around the axle, I can get the car to go a long way. So that's the advantage. It's not an advantage of force like we're normally thinking. It would be an advantage of distance. So I would get a lot more distance out of it for a little bit of string. I'd have to apply a big force, right? And I wouldn't get that much force out of the wheel. But I would apply it a little distance and get a large distance out of it. So that's just the reverse. Normally what we're doing is we're taking the radius of the wheel divided by the radius of the axle to get a force advantage. So an example of this would be like the steering wheel on your car. I can turn this big wheel here to be able to turn the wheels, turn this axle, which turn the wheels. So that's I don't have to put much force in here to get this to work. Or like your water faucets, same thing. Your water faucets are wheel and axles. So I can put my effort on to turn this faucet handle, the wheel, and that easily then turns the axle for me. So I can put a small amount of force on to turn maybe a bigger resistance force. So that's the wheel and the axle.